Today we're going to learn how to construct equilateral triangles two different ways. One using the geometry isosceles triangle tool and the other one using the properties of equilateral. And today we're going to use the CG500 Casio graphing calculator and the geometry app to construct equilateral triangles. We're going to do it two different ways, one using the equilateral triangle tool and the other one using properties of equilateral and our understanding of circles and radii to construct as we would if we had a compass and a straight edge. So first thing, I'm looking at the CG500 graphing calculator. This is the emulator, but right now it's in the mode that looks like what the students might have if they have a handheld version. So it's nice because you have a really large screen compared to most other graphing calculators. So it's a very nice screen. It has a stylus if students are using it. They can easily use their fingers or the stylus to toggle back and forth and look at all the different memories and stuff. But we're going to go into the geometry tool. I'm going to first use it as I would with students who might have the handheld. I want to make it look like what they have, so I'm going to use it in that version first, and then I'm going to switch it to the resizable mode that is allowed in the emulator because then it makes the screen much bigger and easier to work with. So we're going to hit the geometry app. That brings us into the geometry tools. All the tools are across here. There is a video that talks about the tools and what you can do. This is a full-on geometry software, dynamic geometry, so we're going to just be exploring a very small part of it with triangles, but there's a lot more that you can do, and we'll hopefully make more videos about that later. So we're talking about an equilateral triangle, and if you're working with students and you want them to just get right in and figure out what that means to be equilateral, you might want to just use the equilateral tool. So where is that? So there's two ways to access it. You can, up here, you can see these are pictures, and if you open that up, there's different things you can draw. Notice there's three different triangle tools, and so one's just a basic triangle scaling. This one you'll notice has the tick marks, and that means it's an isosceles triangle. This one right here is the equilateral, so I can choose that tool, which is then going to automatically create an equilateral triangle for me. I could also access it through the draw by going to special polygon, and you'll see right here it's spelled out in words. So either way, it gives you this same tool. Once the tool is selected, it's highlighted here in blue. If I click into the screen with my finger, my mouse, my stylus, depending on what I'm working in, it just creates an equilateral triangle right away for me. So as a teacher, this might be what you want. You want them to get right in, everybody make equilateral triangle. Now let's explore what that means. Let's measure angles, let's measure sides, and do some comparison. So let's quickly review how to measure angles and sides. It's very simple in this. This is a full-on geometry tool. So to measure angles, you're going to select the sides of the angle. So notice that as I select something, it's highlighted. I'm going to go up to draw and choose measurement, and angle is one of my options. And there is the angle measurement for that angle that I measured. I can move this on the screen, finger stylus, so I can move it next to what it represents. And so let's quickly measure the rest of them. So I always want to make sure I click on a white spot, but then select what I need, go to measurement, angle, and there's my second measure. I am going to show you how to change the labels on those, but we'll just leave them where they are right now for time's sake. And measure angle. So now we have all three angles. So students might say, oh, well, that's interesting. In this particular example, they're all the same. Is that always true? And this is where the dynamic capabilities come in. You can change this triangle by selecting a vertex and then moving it. And notice it's a different triangle. I could make it bigger, smaller, yet the measures of those angles still remain 60, no matter what size I made that triangle. So is that true? So then students might ask themselves, well, is that true of the sides? Are the sides always the same? Which hopefully they don't think so because they've seen that the triangle changed in size. But let's measure the size. Again, very easy. You select what you want. It highlights. You go to draw, measure, and this time we're choosing length. And so, oh, that's very interesting. I'm not quite sure what we're measuring right now, but that is a very large measure for this length. So let's measure length again. And so what we're noticing that they have the same length measure. It must be pixels. And down here. So we've come to this conclusion. Oh, so all the angles are 60 and they seem to stay 60. All the lengths are the same. Do they stay the same? So they could, choose another vertex to move and change the triangle, and obviously not the same anymore, much smaller, but they are all congruent in length. So whatever the length is, they all have that same length. So these are some things you could explore right away by using the isosceles triangle tool. I'm going to switch now to the other mode that is part of the emulator, which is really nice. So right now it looks just like what the student's handheld would look like, but if I right click, go to resizable, it brings up that screen in a much larger view, and everything then is sort of replaced. Like my menus are now an option here. So I just have things in different places because now I have a much bigger screen, and I can resize it, as it said, make it as big or as small as I want. So I can make it go all the way across here if I really wanted to. I'm going to leave it like this for right now, just so that so it's kind of like a drop-down kind of menu. So notice the picture that I had is now off the screen because I've enlarged it. So one nice quick way to do that is to go up to View and do Zoom Fit, and it'll bring it all back for you. What I'm going to do, I'm going to kind of move these over here. What I did want to point out, it's much easier, especially, and this is nice for teachers, if I'm using this, say, as a demonstration, notice when I click this, I get this little text box up here. I can actually now change these labels to match what's in the image, and that helps me identify better. So now that angle, I don't necessarily have to have it near the B anymore. I could just put it off to the side somewhere, and it will still correspond and student be able to follow things along. So in this mode, it's much easier to add text and things like that. So let's think about the other way, another way that we could construct, and this is more aligned to what students would be doing with their handheld tools of a compass and a straight edge. So compass and a straight edge requires no measurement. It really requires the understanding of properties, of the idea that a compass makes circles, and what do we know about circles? They have congruent segments in them called radii. And how is that going to help us make an equilateral triangle? So we're going to get our compass tool, or circle tool as we like to call it. So that's over here. I'm going to just make a circle. It doesn't matter actually how big I make it, because remember this is dynamic. So I can always change the size of that circle if I want once I make it. So let's think about this. I know I want to make a triangle where all three sides have the same length. And I know radii, the radius of a circle, any radius in a circle has the same measure if it's in the same circle. So if I get my segment tool and make a segment from the center to the outside of the circle, that's a radius. And if I make another one, I know that that is going to be congruent, but how do I get that third one in there? Because I can't, none of these radiuses are going to connect in a way that makes them be a triangle. So I'm going to use my understanding of circles again. If I make another circle that has this same radius, then all its radii are congruent to all of the radii in this circle. So how can I make a circle that's identical to this one without measuring, without anything like that? I can simply use these 2 points in the opposite direction. So here the center is D and radius out to E. Now I'm going to do center E, radius out to D. And so it makes another circle, so different circle, but same radii, because I'm using that distance to the radii to be the radius in each of them. So now whenever I make a radius in either one, they are congruent. How's that going to help me? Well, I can make, if you notice I have intersecting points here, I can make a triangle now, and I'm going to construct this intersection by selecting the 2 circles. And up here I have my tools, and you'll see I'm using the pictures to help me figure out what I'm doing. This one right here is an intersection. So when I click it, it makes an intersection point there. It also makes ones here, so I could use either one. But let's go back and get our segment tool. Now if I do a radius from center D out to this point on the circle, I know that DG is congruent to DE because they are both the radii in the same circle. And if I make another segment from center point E to that same point G, I also know that EG is congruent to ED. So you could think about the fact that if these are both congruent to DE, then they're congruent to each other. That's one way you could think about it. But you could also just look at the picture. These are all radii from circles that have the same radii, so therefore they must all be congruent. So this is a different way to construct using properties versus measurement. But then you could go in and measure, as we did here, measure each of these to confirm that you've actually constructed a equilateral triangle. So two different ways to think about this, and depends sort of what your learning goal is. And we will explore more. Thank you.